Okay, everybody, let's go ahead and talk about how trigonometry is used. So this whole lesson is about story problems, but it's really pretty easy because we always know that we're going to draw a right triangle. No matter what, we're going to draw a right triangle. So there's two terms. One is called the angle of elevation. So if you are looking at the horizon and you take an angle up, that's called the angle of elevation. Different than the angle of depression, which is, if you look at the horizon, like an airplane going down versus sighting the top of a building. Okay, that's an angle of depression there, angle of elevation. Okay, so we took our first example. We said a 6-foot man sights the angle of elevation to the top of a building to be 64 degrees. If he is 100 feet away from the building, how tall is the building? Well, this is a pretty easy problem. We want to find the opposite. We know the adjacent, that's 100, so I'm going to use tangent. So I set up my tangent ratio. Tangent of 64 is equal to my opposite, which is b over my 100. I multiply both sides by 100. I use my calculator, and I get about 205 feet. Last thing I want to do is add in the 6 feet, because when he sights the building, he's taking it from his eye, so technically that triangle is extended by 6 feet. Okay, we've done that problem before. Angle of depression, okay. An airplane 5,000 meters in the sky begins its descent to the airport at an angle of depression of 10 degrees. Okay, how far is the plane from the airport? That's that right there. So this 10 degrees is the angle of depression. So there's a couple ways to do this. You could go to this angle here, and we could use opposite over hypotenuse, which is sine. Some kids wanted to use this angle, the 80 degrees. Wanted to show them that's not the angle of depression. So we decided to use the angle. The 80. 10 plus 80 is 90. So we went cosine because we know the adjacent is 5,000. We want to find the hypotenuse. So cosine of 80 is equal to the 5,000 over x, which is the hypotenuse. I traded places, multiplied by the x, divided by cosine of 80. I used my calculator, I got about 94 meters away, which is about, hold on. Let's see, how many miles is that? Like it's like 16 or something like that. Divided by, not that it matters. About 17 miles away. Okay, turn on the page. This one we want to find the area and perimeter of this isosceles triangle. So I drew an isosceles triangle. Perimeter means to add all the way around. I know the base is 12 and the vertex angle is 40. So the first thing we need to do is make a right triangle. So we made a right triangle out of this. I drew it over here. 20 degrees because I took half of the 40. 6 because I took half of the 12. Now I need the perimeter, so I need to find this side here. So that way I can get the same thing. So what we did, as we looked at this, we looked at opposite over hypotenuse, which is sine. So we did sine of 20 equals my opposite, which is 6 over my hypotenuse is x. Multiplied by the x and divided by the sine of 20. I used my calculator and I got about 17.5. Okay, so this side is 17.5, which means both sides of the triangle 17.5. So I just added perimeter 17.5 plus 17.5 plus 12, which is the base, and I got the perimeter. Now if I also want to find the area, because there's more, I want to find the area also, okay? Because I need the area. To find the area, I know that the area of any triangle is going to be its 1/2 base times height. So I had to find the height, and I found the height by opposite over adjacent tangent, okay? So I did tangent of 20 is equal to the 6 over the height. Again, I multiplied by the height, divided by tangent 20, and I got the height to be about, used my calculator, about 16.5. So then up here I did 1/2 base, which is my 12, times my height, which is 16.5. Multiplied those out in my calculator, and I got the area about 99 centimeters squared. Okay, last problem. We have a pentagon, but it's a regular pentagon. So if I can find the area of one of these triangles, I'll just multiply that by 5. That's what I did eventually, but I'll show you that, okay? So how do I find the area of one of these triangles? Well, I need a right triangle. So I took and I broke it, and we looked at just this little triangle here, okay? So that little triangle is right over there. I just superimposed it, made it bigger. So if that's 10, then that side's 5. Now, if I go around in a circle, I get 360 degrees in a circle. But since I have 1, 2, 3, 4, 5 of those angles, I divided by 5, and I got 72. So each of these is 72, 72 degrees, 72, 72, 72. But I want that angle, so I cut that 72 in half, and I got 36. Okay, now I can do something, okay? So I want the height, because if I can find the height of this triangle, I can get the area of this triangle. Okay, so I want, to find the height, I've got opposite, adjacent, opposite, adjacent. So I'm going to use tangent. Tangent of 36, because that's my theta, is equal to the opposite, which is 5, over the height, which is the adjacent. Okay, when I multiplied by the height, divided by tangent 36. So 5 divided by tangent 36. I use my calculator, which I'm not showing, but you can do it. And I ended up getting about 6.9. Okay, now I can do something. I can go back and find the area of a triangle. Okay, so the area of a triangle is 1/2 base. Well, the base is 10 times the height, which is 6.9. Okay, I use my calculator, and I got about 34.5 for the area of one of this yellow triangle. Multiply that by 5, because I got 5 equal triangles in there. So I multiplied it, and I got about 72.5. I guess that's centimeters, isn't it? Centimeters squared. Okay, and that's all I have. So if you have any questions, come see me.